This video is going to go over surface area. We're going to be looking at a three-dimensional shape, but viewing it in the perspective of a net. Let's go over the definitions for surface area and lateral surface area. Surface area is the whole shape itself. So I'm going to take the sum of all the pieces. I'm going to do the faces that make up the sides, and then the bases, which make the top and the bottom. And remember, sum is a vocabulary word that means add. I'm going to add that to the sentence just to make sure everybody knows what it is. When you look below, lateral surface area is the sum of only the sides, which is also called the lateral faces. We will not add the bases. That's really important. Do not add the bases. Only the lateral faces. So this is a base and this is a base. So I am not going to include that. However, the portion that I am going to include would be these pieces down the center. They would wrap around and end up making the sides. So for this particular 3D figure, these four pieces, they make up the lateral surface area. In this slide, this is just showing you parts of a prism. It's pointing to the portion which is the base. So the part that would be the top. And then if you look through, the part that would be the bottom, those are the bases. It has a rectangular prism has two bases. A triangular prism, just the same. It has two bases, but because the name of it is a triangular prism, the bases are triangles. The other part of a prism is a lateral face. These would be the sides that go around that connect the two bases. On a triangular prism, the lateral faces are still rectangles, but there would only be 3 of them. On this first diagram, we have a rectangular prism, and it's saying that there's 2 congruent bases which make up the top and the bottom, and then it has 4 lateral faces which would end up making the front and the back and the left and the right of the box. So you might imagine this as a cereal box. This would be the top flap and the bottom flap. And then this would be like the left side, this would be the front maybe, the right side, and this would wrap around to the back. So what I'm going to do is I'm going to find the area of the base, and there are 2 of them. The base is the part that would be sticking out. It's not going to wrap around the side, so there's only going to be 2. The dimensions for this is 5 and 2. And because I have 2 of them, they're the same, I am going to put them both in my box over here. And a rectangle is just base times height. So 5 times 2 is 10. And I'm going to do the same thing for the other piece that's congruent. When I add both of those together, that makes 20. Then the other portion of this shape, which are these tall rectangles, which would then make the sides, the front, the back, the left, and the right, those all make the lateral faces. When you look at this rectangle that's on the end, it already has both dimensions. It has the 5 and the 10. And if you notice, the lines that continue to go down all the way across the center of the shape, they are also 10 because they match up with this one. So what I'm going to do is I'm just going to fill that in. There's a 10, there's a 10, there's a 10. And this portion all the way from the left side, front, back, right side, this is the lateral space. and there's 4 of them. So over in my table over here, I've left 4 spaces so I could put each one of these separately in this table. The first one I'm going to do is all the way on the side, the 5 times 10. And if you notice, there's always going to be 2 the same. This one, which would be like the back, this one, which would be the front. They're exactly the same size, so I just need to write it down twice. And 5 times 10 is 50. I'm going to fill both of those in. Then the portion that would be like the little skinny section on the left and the right of the box, that's 2. And the line all the way down, which matched with the other side, was 10. So my last 2 rectangles are going to be 2 times 10. Remember, there's always 2 exactly the same size. Now, when I add these together, I have 50 plus 50. That makes 100. I have 20 plus 20. That makes 40. So now all together, those 4 pieces make 140. If I need to know the total amount of space that it would take to make this entire box, total means add up all the pieces. So I need to include the bases, 20, plus the lateral portion, 140, to end up with my overall answer. So I had 20 plus 140, that equals 160, and this is measured in centimeters, and area is always measured in square units. So my final answer is 160 square centimeters. Now the other type of prism that we're going to be learning about is the triangular prism. It also has 2 congruent bases, but instead of 4 sides, it has 3. It has a left side, a right side, and then the middle. Okay, I'm going to review how to find the area of a triangle. It is base times height and divide by 2. Now the thing you have to be careful of is I'm looking for the right angle. Sometimes it may be up at the top. Sometimes it may be on the side, or sometimes they may have drawn it down the center and your right angle would have been right here. So the key thing is look for this right angle. That's going to tell me the numbers I need to use for base and height. Look for the right angle. The 2 lines that connect it, those are the ones we want to use. It's not always up at the top of the shape though. So be very careful on whatever your diagram is that you're given for the problem you need to do. The numbers now that I need to use are 3 and 4. 3 times 4 divided by 2. And that should be 12. Divided by 2 is 6. Now again, remember that a prism always has 2 congruent bases. They are the exact same size. So I just need to write it down once and then copy it. 3 times 4 divided by 2, that equals 6. And this other 6 didn't look very good up here, so I'm going to fix it. When I put those 2 pieces together, 6 and 6, my bases equal 12 square units. Lateral faces, remember from the last side, that's going to be the section that's connecting the 2 bases. And this time, since it's a triangular prism, I only have 3. And I'm changing colors. Let me get rid of that. Let's go back to blue. All the way from the left side to the right side and that center one, these are my lateral faces. The dimensions for this first one, if you look at the one on the left, it already says 3 times 3. I'm going to put that in. 3 times 3 is 9. And again, whatever this number was for this vertical line going up and down, that's going to transfer all the way across the shape for the vertical lines in the next rectangle. This big one in the center is 5 times 3. 5 times 3 is 15. And then the rectangle that's on the far right side is 4 times 3. Remember, this line was 3, so it's going to transfer itself all the way across the shape. And 4 times 3 would be my last one to add, which is then 12. Okay, 9 plus 15 plus 12 is 36. And again, now that I want to find the total space, I want all the pieces. I want the lateral part, and I want the top and the bottom. I'm going to add those up to get the final answer, which would be 12 plus 36, and that equals 48. And this one it doesn't have a label on there, so I'm just going to put units and then squared.